Hi guys, so I'm going to be doing the Unit 2 review here for geometry, so let's get started. So number 1 asked me to construct a line segment. It's known as CD, and we want CD to be equal to the length of AB. Okay, so I'm going to start by putting a point. This is going to be C. I'm going to draw my line here. Okay. Then I'm going to use my compass to measure how big AB is. So here, AB is this long. So with that measurement, I then move to C, cross the line. Okay. And so here is where D would be. And so here's CD, and it is equal to what AB is. Okay, so now let's do the next one. So here I'm going to construct DE. Okay, so let me put a point for D to be. Let me draw my line. Okay. And what we know about DE is that it consists of TR plus PS. So I'm going to start by measuring TR. Okay. So TR is here. Then I'm going to cross it. So here's TR. It's not just TR, but it is also PS. So I'm going to measure how long PS is. Okay. Too short. Okay. There you go. Then from the end here, I'm going to make an arc. Okay. And there you are. Okay. And so this is where E would end. Okay, so this distance here is TR. This distance here is PS. So together TR plus PS will give me DE. Okay. So now let's construct a perpendicular bisector. So perpendicular bisector, we start at one end of our segment. We open our compass to slightly more than half, or you can do a lot more than half. Okay. We do an arc above and below. Okay. Then, leaving your compass the same, you go to the other end of the segment, and you make an arc. Okay. Then, where these two intersect, that is your perpendicular bisector. So, it just cuts it in half, and it creates that 90-degree angle. Okay. So here, let's do it again with DE. So I start at one end. I open my compass to slightly more than half. I do my arc. Okay. Then, leaving my compass the same, I go to the other end, and I do my arc. Okay. And there, where it intersects, I connect. And there's my perpendicular bisector. It cut it in half and creates a 90-degree angle. Okay. So here's the next one. We're going to construct angle B so that B is congruent to A. So I'm going to start with a ray. Okay. It's going to be called angle B. Okay, and so here we are copying angle A. So what we do is from A here, we're going to open our compass. Any length is fine as long as it crosses both legs of your angles. So here I'm going to cross it. Okay. Then from here, from this vertex of the angle, I'm going to go to the vertex of where my new angle is going to be. And I'm going to do the same arc. Then to figure out how big my angle has to be, from where it intersects, I'm going to measure the intersection. Here it is. Okay. Once I have it measured, right, from this intersection, I'm going to go to this intersection here. I'm going to make an arc. Right, and that measures how wide my angle is. All I have to do is connect the vertex of my angle to this intersection. And now I've copied my angle. So here we're going to do the same thing, but we're going to copy it twice. So here angle D is 2 of angle C's. So again, I'm going to start by making one leg. Okay, so this is angle D, so I'm going to label it angle D. Okay. So I'm going to start with the vertex at this angle, and I'm going to make an arc. Right. Again, doesn't matter how big or how small, it just has to cross twice. Then I'm going to go to the vertex here, and then since I'm going to actually double it, right, because it's 2 of angle C's, I'm going to make sure that my arc here is a little bit longer. Leaving my compass the same, starting at D, I make my arc. Then I need to measure how big this angle is so I know how to copy it. Okay, so here it is. I move to this intersection here. This copies C once, but since I want to double it, I'm now going to move here and do it one more time. Okay. Then this is double angle C. And so all I have to do, go to my vertex and connect, right? So this is one copy of angle C. So this would be 2 angle C's. Okay, and there you go. Let's flip. So here it asks me to bisect angle 1 and angle 2. Okay, so to bisect it, what we do is we start at the vertex of our angle and we cross our angle twice, one on each leg. Then, leaving our compass the same, we're going to go to that intersection. We're going to make an arc. We go to the other side of the intersection and we make an arc. Okay. Where those 2 arcs touch, that is my bisector. So connect from vertex here. There's my bisector. Okay. So I'm also going to bisect angle 2. I'm going to do the same thing. Okay. So from here, I'm going to cross my angle twice. Go to my intersections, leaving my compass the same. Cross it. Okay. Where those 2 arcs touch, that is my bisection. And there you go. And that's 2A constructions. Okay. So now let's move on to 2B, angle pair relationships. Okay. Here it's going to ask for all pairs. I'm not going to do that just because of time. So I'm just going to do one of each so that way you can see the example and that way I can highlight it and you can see. Okay. So it's going to ask for all pairs. I'm checking for all pairs here, but here I'm just going to do one of them. Okay, one of each. Okay, so we're going to start with alternate interior angles. Okay. So alternate interior angles, alternate, right, means opposite side of transversal, right? Okay. So that's what the alternate means. So whether it's alternate interior or alternate exterior, it means the opposite side of the transversal. Interior means in between the pair of lines. Okay, so it's important to know where your transversal is and where is your pair of lines. Okay, so in this picture, this is my pair of lines. This is my transversal. So here, alternate interior, an example would be C and F. So angle C and angle F are examples of alternate interior angles. The other one is D and E. Okay. They are on opposite sides of the transversal, right? This one's on the left, this one's on the right. And they are in between my pair of lines. And that's what makes them interior. The opposite side makes them alternate. Okay. The other one is D and E. Okay. Then, so alternate exterior. Again, alternate meaning that opposite side of transversal. Exterior now means outside the pair of lines. Okay. So that means outside here. Okay. So an example would be A and H. Okay. These are alternate exterior angles. Okay. The other one is angle B and angle G. Okay, when it's same side, it means same side of transversal. We already went over what interior means. Interior is in between the pair of lines. So example of same side interior angles would be D and F. The other pair is angle C and angle E. Same side exterior, again, same side is same side of transversal. Exterior means outside the pair of lines. So an example of that would be B and H. They are on the same side of the transversal, they're to the right, and they are both outside the pair of lines. Okay. Corresponding angles is a little bit trickier. Okay. They are on the same side of transversal. One is exterior and one is interior. Okay. For all of these, they cannot be linear pairs, so keep that in mind, because if it is, it would be considered a linear pair. Okay, so corresponding angles, an example of that would be angle A and angle E. There's a lot of examples of this here. Angle A and angle E, angle B and angle F, angle C and G, and angle D and H. Okay, so I'm just naming one of the pairs. You have to do all of them, though. Okay, then, linear pair. Linear pairs, they are on the same line, and they are adjacent. They are next to each other, and they total 180 degrees. Okay. So an example of a linear pair would be angle C and angle D. Okay. That's one of the examples. Okay, there's a lot of them here, right? C and D, D and B, B and A and C. Those are all linear pairs as well. And then same thing here, E and F, F and H and G, G and E. Okay. Then we want pairs of vertical angles. So vertical angles happen when two lines intersect each other. These angles are across from each other and they are congruent. So an example of this, I am out of colors. An example would be angle G and angle F. Okay. There's a lot here. Angle E and H are one of them. Angle C and B, and angle A and D. Okay. Here, there's nothing to answer. I just want you to make sure you know all of the angle pair relationship postulates and theorems. And all of the properties of equality. You're going to need to know that for your proofs. Okay. So now let's actually apply those postulates and theorems to solve this. Okay, so here we're going to solve for the given variable. Then we're going to provide the angle pair relationship postulates or theorems. Okay. So here, this 110 and the 4x minus 5, okay, they are formed by parallel lines. Note that there's this little symbol arrow here that tells me they're parallel. And because they're parallel, these two angles, not only are they corresponding angles, but because they are formed by parallel lines, the corresponding angles postulate tells me that they are equal. Okay? But this only happens, corresponding angles are only equal when the lines are parallel. Okay? So here, that means 4x minus 5 equals 110, since they are congruent. Okay? I'm going to add 5 to both sides. I get 4x equals 115. going to divide by 4. Okay. And so x equals 115 over 4. If you want, you can change it into a mixed number. I'm okay if you leave it as a simplified fraction, though. So 115 over 4. You can also give me 28 and 3/4, or you can give it to me as a decimal as 28.75. They all say the same thing. Okay. Then let's do the next one here. So here, again, I see that they are parallel lines, which means that I can use my postulates and theorems about those angle pairs. 87 and this x plus 44, what they are alternate exterior angles, and because they are formed by parallel lines, the alternate exterior angles theorem tells me that they are congruent. So that means x plus 44 equals 87. And when I subtract 44 on both sides using the subtraction property of equality, x equals 43. Here's the next one. So here, keep in mind I am pointing at this and this. Okay. I know that these lines are parallel, so I can use those postulates and theorems. Okay. And then, because they are formed by parallel lines, these same side interior angles are supplementary. Okay. So because they are formed by parallel lines, the same side interior angles theorem tells me that they are supplementary, which means that they add up to 180. So x plus 20 plus x minus 20 equals 180. When I combine like terms, I get 2x equals 180, which means that x equals 90. Okay. And then here, this is a linear pair. Okay. And so the linear pair postulate tells me that these two angles are supplementary, which means that they add up to 180. So 7x minus 60 plus 3x minus 40 equals 180. When I combine like terms, I get 10x minus 100 equals 180. When I add 100 on both sides, I get 10x equals 280. And then x equals 28. Okay, so moving on. So now we're going to do our proofs. Okay, so proofs are always in order. Okay, so I know some of you guys like skipping around. That's probably not a good idea. That doesn't give you a very good idea of how proofs are formed, especially when you have to do it all by yourself, right? So everything you should be going in order, right? Because everything is based on what came before or what's directly above or any step above, okay? So here I am given, or I'm told, that point V is on line segment UW. We see that. Here's UW. Point V is on it. We're told that UV is 3x minus 1. We're told that VW is x. And then we're told that UW as a whole is 5x minus 5. Okay? And so what I like doing is, as I'm doing the proof, I like to label what I'm given. I like to label what I figured out. Okay, so here, statement 1 tells me point V is on line segment UW. UV is 3x minus 1. VW is x. UW equals 5x minus 5. That was all given to me earlier, right? So given all of this. Okay. Also important, what you have to prove. What is your end goal? You know you're done when you have x equals 4. Okay. So from here, and based on my picture, I can see that when I put UV and VW together, it forms this bigger UW. And so that's what I write here, that UV plus VW gives me UW. This is known as the segment addition postulate. Okay. And what that tells me is that when I add UV and I add VW, that I end up with a bigger segment known as UW. Okay? That is the segment addition postulate. When you add two things next to each other and they become that bigger segment. Okay? Then, since I know what UV is, I can replace UV with 3x minus 1. Since I know that VW is x, I can replace VW with x. And because I know that UW is 5x minus 5, I can replace UW with 5x minus 5. And whenever I replace something with what it is equal to, that is the substitution property. Okay. Then now I want to, again, my goal is to get to x equals 4. So now that I have this, I just need to solve the equation. And so what I do is 3x plus x gives me 4x. There is no other like term, so everything I copy down below, this is combining like terms. In some proofs, they write simplify. Combining like terms is probably the most accurate. Then, as I'm solving this equation, I want all of the x's on the same side. So what I'm going to do is I'm going to subtract the 4x so it's all on the same side. So since I subtracted 4x on both sides to get this statement, this is the subtraction property of equality. And then the last thing I need to do to solve for x is I'm going to add 5 to both sides. And since I did it to both sides to balance it out, this is the addition property of equality. Okay. And let's do this last proof before we do triangle ones. Okay, so one thing I want you to know is for this proof, and same thing with many proofs, depending on what you're given, the more information you're given, the easier it might be, and the more ways there is to solve it. Okay, so one thing I want you to know is that there is many ways to prove this. Okay, so this next one we're doing, there's many ways to prove this. Okay, I'm just showing you one of the ways. Okay, so here's my two columns. I'm going to do statement and reason. If you're unsure if your way works, please let me know. I can check it for you. This is just one of the ways you can do it. Okay? So before we start, it's important to know what we know and what we're proving. Okay, so I am told that M is parallel to N. So I'm just going to draw that symbol here. Okay, so I know, and this is important, I've told you this before, that when it tells you that something is parallel, it wants you to think in terms of those angle pair relationships. Okay? My end goal is I want to prove that angle A and angle G are supplementary. Okay, and the important thing about that is that means I'm probably going to try to talk about things that are related to angle A that also relate to angle G. Okay, so let's get started. So here I'm going to start with my statement. Okay, and the one thing I know first is that M is parallel to N. Okay. And the reason I know that is because that was given to me. Okay. Again, thinking ahead that my goal is to connect angle A and G, one of the angles that they both have relationships with is angle D. Right? So again, like I said, there's many ways to prove it. This is just one of them. Okay? So I'm going to relate angle A to D, and I'm going to relate G to D. Okay? So let's start with A and D. So one thing I know is that angle A is congruent to angle D. Okay? And the reason why is because they are considered vertical angles. So the vertical angle congruence theorem tells me that vertical angles are congruent. Okay. So I've connected A to D. So now, since I want to prove A and G are supplementary, I'm going to relate D to G. Okay. And how D and G relate is that angle D and G are supplementary. Okay. And the reason why angle D and angle G are supplementary is because they are same side interior angles that are formed by parallel lines. So if I'm going to use this theorem, okay, I need to first have this given statement, which is why it was so important that they told me this. It is only because that they are parallel that I'm able to use this theorem. Okay. So because they are formed by parallel lines, these same side interior angles are going to be supplementary. And that is because of the same side interior angles theorem. And since A is congruent to D, and D and G are supplementary, that must mean that angle A and angle G are supplementary as well. And the reason for that is because of the substitution property. Because if A and D are congruent, they are equal to each other, that means wherever angle D is, I can substitute it with angle A. Okay? And so this is one of the many ways you can prove that angle A and angle G are supplementary. Okay? Let's flip. Okay, we are on our last section, which is to prove that triangles are congruent. Okay. So here, what I see is that I have two sides. The sides are congruent. These angles are congruent. And because they share this side, that means these sides are congruent. Okay. And so I can prove that these triangles are congruent because of side, angle, side. So side, angle, side, congruence postulate. Okay. This one, I know that these sides are congruent and these sides are congruent. However, there is nothing else I can prove or know about this. So since all I have are these two sides, this is not possible. Here, I see that I have congruent angles, congruent sides, congruent sides. So you would think that this is angle, side, side. Or you might think if you read it the other way as side, side, angle. However, this doesn't exist. And so it is not possible. Okay. Here's the next one. So here I have a right angle, 90 degrees. So these are congruent to each other. And I know that one of the legs is congruent. However, all I have is the angle in this leg. And so I don't have enough information to prove that they are congruent. So this one is not possible also. Okay. Here, I have an angle. They share this side. So reflexive property tells me that they're the same. And then I have this angle here. So this is angle, side, angle. Here, I have an angle. I have this side. And based on this picture, I also know there are vertical angles, which would make this angle and this angle congruent. And as a result, now I have angle, angle, and side. And so this is provable by the angle, angle, side congruence theorem. Here's my next one. Okay, so here I have a side that are congruent, a second side that is congruent, and a third side that is congruent. And so this is side, side, side congruence postulate. Okay. This one, all I know is that here and here is 90 degrees. Right? If it's a linear pair, this is 90, this is 90 here. I know that this side is equal. Okay. But since that's the only information I have, I don't know anything else, it is considered not possible. Here, I have side that is congruent, an angle that is congruent, they're both right angles, and then a side, so this is side, angle, side. Here's the next one. Okay, so here I have a side, I have an angle, and then based on this picture, I also have vertical angles. And so this would make it angle, angle, side. Here's the next one. So I know there's a side. Okay, I see vertical angles, so that would be here and here. However, there is no other information. So since not enough information, it is not possible. Okay. Here's the next one. I have an angle. I have a side. However, there is no other thing I can prove. So again, not enough information, so it's not possible. So here I have a side, I have an angle. They also share a side, so reflexive property tells me that it would be congruent to itself here. So here I have side, angle, and side. So this is the side, angle, side congruence postulate. Okay, here's my next one. So I have a side here, and because they share a side, this is congruent to itself. And so as a result, I have side, side, side. So here, next one, I have a side, and I can also see that there are vertical angles here. So this and this is congruent. So then it's angle, side, side. However, angle, side, side, or side, side, angle does not exist, and so this would be not possible as well. Okay. Here's the next one. So I have an angle, a side, and then an angle, and so this is angle, side, angle congruence postulate. This one here, I have a side. They share a side. However, other than that, there's nothing else I know, and so this is not possible. Here I have an angle, I have a side, and since there are vertical angles, I know that here is congruent as well, and so this is angle, angle, side. And so let's flip. This section here is asking you to use what we know about isosceles triangles and linear pairs. So here, starting with this is a linear pair. So if I do 180 minus 125, that will give me 55. And so x is 55 degrees. Then, because I have an isosceles triangle, if the sides of a triangle are congruent, the angles across from them are congruent. So since opposite here, this is 55, here would have to be 55 degrees as well. Okay. And then since this is a linear pair, if I did 180 minus 55, I would get 125. And so z would be 125 degrees. Then, to find out what y is, since this forms a triangle, triangles add up to 180. 55 plus 55 plus y would equal 180. 55 plus 55 is 110. Okay, which would mean that y is 70 degrees. Here's the next one. Right, so here I have an isosceles triangle, which means that congruent sides opposite to them is congruent angles. So since this is 55, this would be 55 as well. And since triangles total up to be 180, again, that 55 plus 55 plus x here would equal 180. 55 plus 55 is 110, which would make x equal to 70 degrees. And since this is 70 degrees, that would make this 70 degrees as well. And then, because we have an isosceles triangle here, would be the same thing. So if this is y, this would have to be y as well. And so what that means is that y plus that 70 from the vertical angle would total to be 180 for that triangle. This would give me 2y plus 70 equals 180. This would be 2y equals 110. And so y would equal 55. Here's the next one. Okay. So here, this is a linear pair. So they total to be 180. So if I did 180 minus 110, that will give me 70. So x is 70 degrees. Then here, since this makes a little small triangle, and I know that this is 90 degrees, 90 plus x plus y would equal 180. We know that x is 70, so 90 plus 70 plus whatever y would be equal 180. 90 plus 70 is 160, and so that would make y 20 degrees. So that was nice and fast, but this just deals with isosceles triangles and linear pairs. Okay. So now let's get started on triangle proofs. Okay. Again, it's important what you are given and that you understand what it is. What I normally do is that once I'm given something, I would mark it in the picture if I didn't know that already. Okay, so the first thing I know is that LT is congruent to TR, right? So I would then mark it in my picture that LT and TR are congruent. Okay. I would write it down as my statement. And the reason I would know that is because that was given to me. Okay. The next thing I know is that angle ILT and angle ETR are congruent. So ILT is here, ETR is here, they are congruent. Okay. I know that because that was given to me. Okay. Then the third thing I know is that IT is parallel to ER. Okay. The reason why that is important is, again, probably because of angle pair relationships. So I'm going to mark that IT and ER are parallel. This does not mean that they are congruent. Okay. So that is given to me. That is important information because I can then use my angle pair relationships for that. Okay, so what I'm going to do is I'm going to draw IT and ER. Okay, so I'm going to draw them separately. So IT, ER. I'm going to label it IT, ER. So I kind of separated my picture so I can see it in a different way. Right? This doesn't always help, but sometimes this is useful. So I'm going to pull it out, IT and ER, they are parallel. Okay. And then I'm going to use one of my lines as a transversal. So here I'm going to use this as my transversal. Okay. And when I do that, what I see is that I have corresponding angles, which would make this and this congruent because, not just because they're corresponding, but because they are formed by parallel lines. That would make these two angles congruent. And that's why here you see that LTI is congruent to ERT. And the reason why is because they are created by those parallel lines, I can use the corresponding angles postulate. Okay. It is important to know this is only because you can only use this when you have parallel lines. This is only because of that information that was given where IT is parallel to ER. Okay, so note that the corresponding angles postulate only works with parallel line. Okay, so it's because of that that I could use it. Okay, then, so now I'm going to mark it on my picture. So now I have this congruent as well. Then I have enough information to prove that they are now congruent. Okay, so now these two triangles are congruent because of angle, side, angle. Congruence postulate. Okay. And let's get started on the next one. Okay, moving on. Okay. So here, the first thing I'm given is that BC is congruent to DA. So I'm going to mark that. So BC congruent to DA. I'm going to write it as my statement that it is given to me. Okay. Then I know that AC bisects angle BCD. So this is important information because bisect means something more, right? So since AC bisects BCD, that is given to me. So AC here, this line bisects, it cuts this angle. It cuts BCD. And what that means is when it cuts it, that this angle here and this angle here are now congruent. Okay? And so that's why you then see here that because it cuts it, it's congruent. That is why angle BCA and angle DCA right here are congruent. And the reason why is that's the definition of angle bisector. So because AC cuts that angle, it bisects that angle into two equal halves, the angles that result are congruent. Okay. Then, another thing I know based on this picture is that it shares a side. It shares this side here. And so what that means is if it shares this side, that it has to be congruent to itself. And so that's why here AC is congruent to AC. This is the reflexive property when something equals itself. And now I have the requirements for my 5 postulates or theorems to prove that these triangles are congruent. So here, triangle ABC, this top one, is congruent to triangle CDA because of the side angle side postulate. Side angle side. So let's keep going. Okay. Flip to the other side. Okay, a couple more proofs. Okay. So again, important that we see our picture, we mark it and understand what we're given. Okay, so the first thing is that C is the midpoint of BD. Okay. Right, so some people, I've taught you to put everything that you're given in the beginning, and you can totally do that. Okay, some people, they write their given and then they write what it means. Right, so here, C is the midpoint of BD. Important information that is given. Okay, right, so maybe I want to skip next steps instead of writing this given too. Right, because C is the midpoint of BD, so C here is the midpoint of this line segment, what that means is that BC is congruent to CD. And that's why here in step 3, you can see that we wrote that BC is congruent to CD. Okay. And the reason for that is because of that definition of midpoint, that it is in the middle. The other parts are equal, right? And so here, because of this given statement that C is the midpoint, therefore BC and CD are congruent. Okay? And that's the definition of midpoint. Okay? So some people actually do their proof where they would do 1 and then this statement 3, and then they would keep moving on for it. Okay? Then my next statement here is that AB is perpendicular to BD. So AB here is perpendicular to BD, and that BD here is perpendicular to DE. Here you see this. They decided to put all their givens together first. But after that, they are going to build off of that. Okay, and we actually see that right here. Right? So here, because they are perpendicular, what that means, if AB is perpendicular to BD, that means here is a right angle. If BD here is perpendicular to DE, that means here is a right angle. And so that's why you see here that angle ABC and angle EDC are right angles. And the reason why is because perpendicular segments or perpendicular lines form right angles. So based on step 2 of what they were given, they then can conclude that angle ABC and angle EDC are right angles. And because both of these are right angles, what that then means is that they have to be congruent to each other, right? So this leads to the next statement that they are congruent to each other. And the reason why is because all right angles are congruent, because all right angles equal 90 degrees. Okay. So here in this one, since it was given to us, it was written a certain way, right? When we're doing it ourselves, we can write it in the way that we logically see it, right? And so that's why I'm kind of grouping it here instead of going in that order, right? I wanted to show you the connection of what you're given and therefore what you can say next, right? What you are given and therefore what you can say next, right? Then they notice, in addition to this picture, they also have a pair of vertical angles, right? And that is right here and right here. And so then angle BCA right here is congruent to angle ECD right here. And the reason why is because those are vertical angles. So the vertical angle congruence theorem tells us that vertical angles are congruent. And then after that, I have enough to fill out why the triangles are congruent. So here I have angle, side, angle. And so because of angle, side, angle, these triangles are congruent. So angle, side, angles, congruence postulate. Okay. So let's do our next one here. Okay. So here, again, important that we know what we are given, because that's going to direct what we're going to do. So let's get started. Okay, so first thing I know is angle ADB and angle CDB are right angles. Okay, I see that here. Then I also know that angle A and angle C are congruent. So let's get started. Okay, so I'm going to make my 2 columns. I'm going to fill it out. So statement and reason. Okay. So first, angle ADB and angle CDB are right angles. That was given to me. The other thing I know or I'm given is that angle A is congruent to angle C. And again, the reason for that is they are given to me. Okay. Nothing more I can do about angle A being congruent to angle C. However, because angle ADB and angle CDB are right angles, that means that they have to be congruent to each other. Okay. And the reason why is because all right angles are congruent. And so because they are right angles, that allows me to say that they are congruent. Because all right angles are congruent. It's the right angle congruence theorem. Because they all equal 180. Then, based on my picture, I know one other thing. They share a side. They share BD here. And so I know that BD, the segment, has to be congruent to BD, the segment. It has to be congruent to itself. The reason why is because of the reflexive property. Then, looking at my picture, I now have angle, angle, side. So I have enough to prove that they are congruent. So statement, reason. Okay, so step 4 then is proving that triangle ADB is congruent to triangle CDB. And the reason why is because of angle, angle, side congruence theorem. Okay. There we go. We are on our last one here. Okay. So statement and reason. Okay. We're going to start by understanding what we're given. Okay. So first, AB is congruent to CB. Okay, so I'm going to mark it here. I'm going to write it. Okay, the reason I know that, it was given to me. Next thing I know is that BD is a median, so that's important to know what that means. Okay, so here, I'm going to write it together. Okay, BD is a median of AC. Okay. Again, that is given to me. Okay. There's nothing more I can really do with that first statement of AB being congruent to CB. However, with BD is a median of AC, what that means if BD is a median of AC is that here, AD and CD have to be congruent. Okay. And the reason why is because the median is the segment that goes from the vertex to the middle of a side. Okay? And so AD and CD, this is based on that median statement from before. And the reason for that is the definition of what a median is. Then I see that they share a side. These triangles share this side of BD. And so then I can state that BD is congruent to itself. Okay. That is due to the reflexive property. Okay. And after that, looking at my picture, I now have enough to prove that these triangles are congruent. Because of the side congruence postulate. Okay, that's it. That's all of Unit 2 review. I did it. I explained it. Please let me know if you have any other questions, and good luck on the test. Bye, guys.